What if everything you thought you knew about our universe's movement was wrong? What if, right now, your entire galaxy, a cosmic island of billions of stars, isn't just expanding outwards, but is being relentlessly pulled towards something immense, something invisible, something we can barely comprehend? A hidden force, bending the very fabric of space, dictating our cosmic destiny. For decades, scientists believed the universe expanded uniformly, a smooth outward rush from the Big Bang. But the cosmos holds deeper secrets. Data from far-flung galaxies began to whisper of a different truth, a vast, unseen current, a gravitational anomaly so powerful it tugs at everything in its path. We're not merely adrift in an expanding sea, we're caught in a cosmic river, flowing towards an unknown origin. And its name is the Great Attractor. Imagine you're on a ship, sailing on an ocean. You feel the global currents, pushing you one way. But your ship also has its own engine, propelling you. The universe is like that, but on an unimaginable scale. We know the universe is expanding, carrying galaxies away from each other. But individual galaxies, like our own Milky Way, are also in constant, frenetic motion. Our sun orbits the galactic center at over 500,000 miles per hour. Our entire galaxy, the Milky Way, is itself rushing through space at an astonishing 1.3 million miles per hour. That's over 360 miles every single second. But where are we going? And why? This isn't just random cosmic wandering. This incredible speed isn't towards some arbitrary point. It's a deliberate, directed rush. For a long time, the source of this peculiar motion was a profound mystery. We knew we were moving, but the destination, the why, remained elusive. It was like feeling an unseen hand push you, without ever seeing the hand itself. This observation, rooted in the faint afterglow of the Big Bang, the cosmic microwave background, or CMB, revealed a startling asymmetry. One side of the sky appears slightly hotter, the other slightly cooler. This isn't because of a temperature difference in the early universe, but because of our own motion. We're rushing towards the hotter region, experiencing a cosmic headwind of photons. So, if we're moving, what's pulling us? Scientists began to map the universe, not just for individual stars, but for galaxy clusters, superclusters, the largest known structures. And they found a pattern. Hundreds of thousands of galaxies, spread across millions of light-years, all seem to be flowing in a single direction. They identified a massive, diffuse gravitational anomaly in the direction of the Centaurus and Hydra constellations. They named it the Great Attractor. It's not a black hole, not a single superdense object. Instead, it's a vast, diffuse region of space-time, hundreds of millions of light-years away, containing the mass of tens of thousands of galaxies. An immense concentration of both visible matter and, crucially, invisible dark matter. Think of it like a giant cosmic bathtub drain, slowly pulling in the water. Except the water is entire galaxies, and the drain is an immense, mostly unseen gravitational well. Our own local group of galaxies, including Andromeda, is hurtling towards this Great Attractor. Even the Virgo supercluster, our larger galactic neighborhood, is flowing towards it. It's like discovering we're all part of a colossal river system, and this attractor is a major confluence point. But the mystery deepened. While the Great Attractor explained a significant portion of our motion, it didn't quite account for all of it. Our speed was still too high, our direction still too precise, for the Great Attractor to be the sole culprit. What if the Great Attractor itself is just a waypoint? What if it's merely a larger river flowing into an even greater ocean? This brings us to one of the most intriguing and controversial hypotheses in cosmology, the dark flow. Observations in the late 2000s suggested that galaxy clusters weren't just being pulled towards the Great Attractor, but that the Great Attractor and its surrounding cosmic neighborhood were also moving, en masse, in a consistent direction. This flow seemed to extend far beyond the Great Attractor, into regions of the universe we can't even see with traditional telescopes. This dark flow is hypothesized to be caused by gravitational influences from beyond the observable universe. Imagine a vast ocean stretching infinitely, but you can only see a small circular patch from your boat. If currents are pulling your boat towards the edge of that patch, it could be due to something within your visible circle, or it could be a much larger current originating outside your view, beyond the horizon. The dark flow suggests immense structures, perhaps left over from the Big Bang, or even from a multiverse scenario, are exerting gravitational pressure on our entire observable cosmos. It's a force so immense, so ancient, that it predates the formation of stars and galaxies, acting as a cosmic tide pushing and pulling the very fabric of space-time. This discovery fundamentally shifts our understanding of the universe's large-scale structure. It's not just a collection of isolated galaxies, but a vast, interconnected cosmic web filaments of galaxies and dark matter